in this video, we are going to take a look at the release questions from 2018. We're just going to do a few of the problems though, and then I'll break it up into some different videos. But we will go ahead and get started. This is actually number 2 from your assignment. So if you do want to click into your assignment or if you want to look at it, you can with number 2. One thing that I want to point out is if you look at this, remember that proofs go from one step to the next. I do recommend that a lot of times you start at the beginning, but if you start at the beginning and you feel kind of frustrated or anything, try looking always from this step like down 1, 2. If we look at step 3, it says jk squared is equal to lk times mk, and lj squared equals lk times ml. Well, we're just using the addition property, so if you take a look at the addition property, which one of these makes sense? Well, we have this being squared and this being squared. So if you look here, that doesn't make sense. We don't have 2 jk squareds, and that takes away 2 of your solutions already. Then if you take a look at what's left, the difference between these two, you're just using the distributive property, which is another, it's a property from algebra even. And if you take a look here, you have LK and an LK. So what this is saying is that you're pulling this out in front, and then this is what's left. So that makes sense. If we take a look down here, if we're pulling this out in front, then this is what we should have left in our parentheses, but we do not. So that is why A would have been the answer. Technically, you could have started from the very first step. You could have tried to see how, once you take a look at which triangles you have, they are similar. Remember that with similar figures, your sides are proportional. So these are the proportional sides that match up. Going from step 2 to 3, you're just cross multiplying, and so that's kind of how you get to this step. But sometimes just looking at the step before can be really helpful too. So if you do start at the beginning but you feel like you're getting frustrated or you're having difficulties, maybe try looking at that step that's right before and see if that's enough to be helpful. But definitely start from the beginning if you can and then kind of go from there. This one would have been A. This is technically number 1. Sorry, I didn't realize they were backwards on here, but this was number 1 on our assignment. And if we take a look at this one, we want the cosine of A. And the cosine of A, we think of our trig functions. We need SOHCAHTOA to show up here. Cosine is adjacent over hypotenuse. If you forget these, you can keep in mind that you have that reference sheet. And this is on there. So it doesn't give you the little triangles and stuff, but those definitions are on there. So this is our angle. Remember, this is always the angle that you want to mark. So it does matter which one you look at. You want to look there to see which one. Then you can figure out your sides. The hypotenuse is always across from the 90-degree angle. So this is the hypotenuse. Since we also want the adjacent is the other one that touches your angle. So if our angle is right here, this would be the adjacent. So the cosine of our angle, which is the cosine of A, is equal to adjacent over hypotenuse for 8 over 17. I would recommend just putting it in the fraction form. If you do want to switch it to a decimal, you can. However, you do have to make sure that you would leave a couple decimal places, so 0.47 it would accept. It would also accept, the test would accept like 4.7 or 0.471. But if you would have rounded it to 0.5, you would have had it incorrect. So please make sure if you put the fraction, that's definitely a little bit of a better answer. But if you do put decimals, then you do want to make sure that you give plenty of details. And it would have accepted any number in between. If you would have listed out 3 or 4 decimal places, that would have worked too, but you would need at least a couple to get credit for this one. Number 3 says line K has a slope of -5. We need line J that is perpendicular to line K and passes through the point 5, 9. First thing you want to think about is perpendicular. Remember that perpendicular is opposite reciprocal? We learned about perpendicular and parallel kind of at the same time. Parallel means that you have the same slope. Perpendicular means opposite reciprocal slope. Opposite just changes your sign. Reciprocal means flip your fraction. Alright, so if we have a slope of -5, we'll go down here, let's write that out. If we want the opposite, we change our sign, then we're going to have a positive number. If you want to flip your fraction, if you have a fraction, that's easy. You just flip it. If you don't have a fraction, though, how -5 is a whole number, then you put it over top of 1. So your new slope is going to be 1/5, and we want it to go through the point 5, 9. If you recall, I think it was back in chapter 3, we had the point slope formula. So since we have a point and we have our slope, that's going to be the easiest one to use. Y minus y of 1 equals mx minus x of 1. Your point is considered your x of 1, y of 1, and your slope is considered the m, and you just plug in those values. So y minus 9 is equal to 1/5 x minus 5. Now, it doesn't say, to write it in slope-intercept form or do anything else, so this could actually just be your final answer. We did see several examples when we were in this chapter where you did have to put it into slope-intercept form, so I am going to finish those steps out just in case this year maybe it says that. But that could be your final answer for this one. If it would have said to put it into slope-intercept form, then you solve for y. In order to do that, we could distribute that 1/5 through. Y minus 9 equals 1/5 x, and then 1/5 times a -5 will give you a -1 though. And then if we just add 9 to both sides, you get y equals 1/5 x plus 8. So again, this is slope-intercept form, which is the y equals mx plus b. And either way that you could have put it in would have been correct. If you would have solved for y, you would have gotten credit for this equation. You would have gotten credit for the first one. The only reason I recommend the first one is because why do more work? You have a chance of making a mistake. If it doesn't say which equation, then it shouldn't matter, as long as you just provide an equation for line J. If it does say a specific one, though, then you definitely want to keep that in mind. And then if we wanted to, you could graph this. I'm just wanted this up here as a reminder, but just use Desmos. So what can you use Desmos for? To check your work. You can't use it, in this case, to create your equations, but you can use Desmos to check. And I was afraid I would forget to say that, so I'm glad I put the little graph in there. But if you plug in your two equations, the one that you're given and the one that you just found, into Desmos, you should be able to see if they look like they are perpendicular or not. So that's just one way to check your work. Jeremy wants to know the density of a rock in grams per cubic centimeters. The rock has a mass of 1.08 kilometers and a volume of 400 cubic centimeters. What is the density of the rock in grams per cubic centimeters? Alright, so one thing to keep in mind. Do you know the definition of density? You may or may not. One thing that can kind of give it away and help you out is this right here, though. Since it says grams, we know that that means you're probably putting this up first. However, we are given 1.08 kilograms, and that's going to have to just go into grams. This is considered a unit conversion. If you look at your reference sheet, they give you conversions on there. You should see that kilograms, kilo, the K-I-L-O, means 1,000. And so if you multiply this by 1,000, then you have 1,080 grams. This is basically giving you your definition of density, because your definition of density is mass over volume, but your mass is the grams. So if we put our grams on top, because that's exactly what's in those parentheses, over the cubic centimeters, because the centimeters cubed, That is your answer. So that's all you had to really do for this one, is just make sure that you understood that this is really just a ratio. You're really just seeing, if you put this piece of information in, that just creates your ratio. But you do have to watch to make sure that you put it in the correct unit of measure, since it was wanting in grams. So that could be your final answer. If you do divide that, you could have also put 2.7. So you could put into this little box this, and you don't have to reduce it either. You would have gotten full credit just for that. Or if you did divide it, you would have 2.7, and that would have been acceptable as well. This is a two-way frequency table. It's for number 5. We will do two-way frequency tables before the end of course exams. There were actually several last year, and so we definitely want to make sure that this is a topic that we cover, just in case there's just as many this year. So it says the two-way table shows the number of births in thousands in the United States for the years 2010 and 2011. A baby born in 2011 is randomly selected. So we are only looking at those born in 2007. This is all just additional information that they give you to make it look harder. So we just want to look at data from 2011. What is the probability that a baby was born in February? Like I said, we're going to do probability, we're going to do frequency tables, but basically what you want to look at is if it's born in February, that's what will go on top. And so a baby's born in February this year is 299. That is over the total, and so your total is 3,966, and again, that is your final answer. A lot of times these aren't quite as challenging. I know a lot of you may have had difficulty when you were going through these because the problems do look different, but that is one reason why I wanted to make sure that you got to practice them before we just go over them together, so that you can learn from them and hopefully understand them a lot better. Probability is definitely something that we will go over before the test though. So for this one, you could have 299 over 3,966, or you could have put it as a decimal. If you did though, you would have had to have included several decimal places in order to get credit. That's one reason why I would recommend just putting in those fractions. But any number between those two is what it says that it would have accepted for last year. So in this video, we looked at the first 5 problems. I'll make additional videos so that you can continue to look at more. I just didn't want it to be too long all at once. So if you have any questions, please let me know.